Hello, this is USACO 2020 December Contest Silver stuck in a rut. I will first explain the problem, then I will show you how to do it. Farmer John has recently expanded the size of his farm, so from the perspective of his cows, it is effective now infinite in size. The cows think of the grazing area of the farm as an infinite 2D grid of square cells, each filled with delicious grass. Each of Farmer John's and cows start out in a different cell, some facing north, some facing east. Every hour, every cow either stops if the grass in her current cell has already been eaten by another cow, eats all the grass in her current cell, and moves one cell forward according to the direction she faces. Over time, each cow therefore leaves a barren rut of empty cells behind her. If two cows move on to the same grassy cell, the same move, they share the cell and continue moving in their respective directions. Farmer John isn't happy when he sees that cows that stop grazing, and he wants to know who to blame for his stopped cows. If cow B stops in the cell that cow A originally ate, then we say that cow A stopped cow B. Moreover, if cow A stopped cow B and cow B stopped cow C, we can say that cow A also stopped cow C. Each cow is blamed in accordance with the number of cows she stopped. Please compute the amount of blame assigned to each cow, that is, the number of cows she stopped. Each line contains, the first line contains n, and each line after that contains n or e, and two non-negative integers x and y, giving the coordinates of the cell. If it moves north, x and y become xy plus 1, and if she moves east, x1, comma y. So basically, what this problem is saying is that let's see how many times how many cows a certain cow stops. And how does a cow stop another cow? That means that cow has eaten that position before that next cow can come and actually eat it. So we just gotta check how the cows go and how the cows will meet. Okay, to do that, first we will have to import things. Next, we need to make a few static variables. Static scanner to get the inputs, static int n to see how many inputs we can get, static int distance that will check like the distance the cows move, and stuck. Static Boolean stuck that will actually check which cows get stuck. And then we're going to actually make two linked lists, static linked list cows for E and N. These will be holding the cows that moves east or north. As you see, cows is not an existing class. Therefore, we're actually going to make that right now. Static class cows int id x and y cows int a, int b, and int c. Order does matter, so please maintain that. X equals b, y equals c. Indentation also is very important. And then we're going to make the toString public string to string return id plus y. And now we're actually going to start initializing the in scanner, which is in new scanner system in. And then we're going to have to call init and solve because they technically are methods. Then we're going to have to close in at the end. So after we do that, we got to start initializing our variables. So we're going to do an equals in the next. We're actually going to do integer.parse int in the next line to actually get int n, and then we're gonna initialize dist new dist n, and same for stock. Yes. And like that. Remember, always check your things. And then we're gonna actually initialize the two linked lists, new linked list files. And then north and east, since we have two linked lists, and then we're gonna make a for loop that actually holds this to actually like initialize these two and actually put things into it. And then I plus plus char d. Char d will hold which direction it goes into. That char at means it's to make it into a character instead of keeping it as a string. Int x equals int dot next int. And then we will do the same for y and dot next int. And let's say, since we have two linked lists that already established which direction the cal is going to go, we just need to know which, we don't actually need to hold the direction. What we need to know is which cal is actually doing that. So we will just check this D is only to check which direction it's going, like temporarily to put it into a separate linked list. So it will be linked list equals e dot add new cows, since we're technically making a new cow, x, y. I will be the position number, the ID in a sense. And we will do the same for north, not just east. And then we're actually going to make a comparable statement here, collections.sort E, because we're collection.sort because we're trying to sort E in this case by Y. We're sorting by the Y coordinates, a new comparator, cows, and then like this, go in, at override since it's always required, public int compare stuck silver. That's the name of the file because cows exist within this file. So we need to keep that in mind and then do the same for O2. Stuck silver cows O2. And then we're going to return in O1 the y minus O2 dot y, which is the variable. And then we gotta actually, and we're gonna actually, what we're gonna do next is actually just copy and paste this. But instead of keeping this as E, we're gonna change it to N and change that to X since we're comparing by X, not Y. And then we're should be set for initializing the variables. Next, we're gonna move on to solve. So what is solve? Solve is actually going to be the place where we check where things get stuck and how we're actually like do things about that. So in solve, we're going to make two for loops, cows E and for cows and then in there we gotta check if a cow gets stuck or not. Basically, if dot x is less than e dot x and dot y is greater than e dot y, or the cow is stuck at this position and the ID, or it's already stuck at the E position, E.ID. Then if that's true, we just continue. Let's say it doesn't get stuck. Then we gotta check when it does get stuck. So we're gonna do int dx equals n dot x minus e dot x, and dy, which is the distance between the y's, is gonna be e dot y minus n dot y. And then what we're gonna do is compare dx dy. Let's say dx is greater than dy. Then what do we do? Then at this position, stuck at e dot id, it will become stuck. The cow going east will be stuck. And distance at n dot id, instead of distance, we could have called it count, but I just chose distance for this because if you look at a previous example of the same code, which is going to be stuck in the bronze version, we used distance, but for the sake of sanity, we will just continue on. And e.id, we're just going to add one more than that cal because it is transitive. and then else, and then else if dy is less than dx, we're actually just going to do the opposite of basically this code as the one above. And then at the end, we're just going to basically add everything into a string builder for the sake of convenience of printing it. So string builder sp equals new string builder for int n is this, and then we put sp dot append n dot append, and then we add a backslash because each line of output has to be on a different line as such. And then we just do system that out dot print because there is not println because there's a backslash n at the end already, sp dot to string, and voila. Let's see if this works. Copy, paste, and if you look, it works. And that's how you would go about solving this problem. Silver stuck in a rut. I hope you learned something, and I hope to see you next time.